Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the October-November 2020 Pure Mathematics Paper 1 Variant 2 from the Cambridge 9709 syllabus. And this question here is about series. And here we're told that the sum Sn of the first n terms of an arithmetic progression is given by this formula Sn equals n squared plus 4n. The kth term in the progression is a term greater than 200. Find the smallest possible value of k. So this question here, I think the simplest way to deal with this question is to actually generate some of the like the sum of the first term of the series. When you put n equals 1 in here, this formula tells you the sum of any particular number of terms of the series that you want. So if I put 1 instead of n, that's going to give me actually the first term of the series, because if you just add the first term of the series, what it means is it's just going to be the first term. Okay, the first term of the, it's just going to be the first term, which is called a. This would be 1 plus 4, which is 5. So the first term of the series is 5. Why? Because you add this, the first term is just going to be itself, basically. Now, when I put n equals 2 in here, it's going to give me the sum of the first two series. So let me call the second term x. Right, so when n equals 2, then we can say the sum of the first two terms is going to be 2 squared plus 4 times 2, which is 4 plus 8, which is 12. So I can say here that the sum of the first two terms is going to be 5 plus x, okay? And we know that 5 plus x has to equal 12. That means x must be 12 minus 5, which is 7. So the second term of the series is 7. So you have 5 and 7. And you can see that if it's an arithmetic progression, every time you have to change by the same amount. So the next one is going to be 9 and so on. So we can see this series is going to have a first term of 5 and a common difference of what you have to add each time, which is 2. Once we've got that, that's going to help us now to answer the question. Okay, because next we want to find the term in the progression which is greater than 200. Now, to find a particular term in an arithmetic series, this is something you'll find in the formula book, and it's un equals a plus n minus 1 times d. This is the nth term of a arithmetic series. A, first term, d is the common difference, and n is the term that we're on. So in this case, we know that k is n is equal to k. That's the term we're thinking about, the kth term. So n is equal to k. And the term we're looking at, it's going to be a term which is greater than 200. So let's find out which term is equal to 200 first. Okay, I'm going to make it equal to 200 and then we'll deal with it. So here we have this formula we will use. So we know that a, which is 5, plus n minus 1, which is k minus 1, times d, which is 2. I want to find the value of k for which this equals 200, and then I can deal with greater than or less than. So now this will give us k minus 1 times 2 is equal to 200 minus 5, which is 195. So k minus 1 is equal to 195 divided by 2, which gives you 18. 2 into 9 goes, sorry, that goes, 2 into 19 goes 9 times, remainder 1. 2 into 15 goes 7 times, so 7.5. So k minus 1 is equal to 97.5. That means k is equal to 98.5. So of course, k cannot be k is basically a term. First term, second term, third term. It has to be an integer. So basically the 98th term will be a term less than 200. And the 99th term is going to be more than 200. Okay, so that's going to be the first term, which is greater than 200. We could have used inequalities here. There's no problem in this particular question. I mean, I prefer to use equations and then in the end, just make sure that I write my number down as a whole number. Okay, but you could easily done this. And k is greater than 98.5. So the next time it's going to be an integer, will be the 99th term. Okay, we could have done that. And we could have done this in other ways as well. A bit more complicated ways. I could have, for example, used the formula for the sum of the first n terms of a series, which is n over 2 times 2a plus n minus 1 times d, and equated this to this, okay, and try to find the value of a and d by equating these two together. But I think that's way more hassle than doing this. This is a very easy way of doing it. This generates the sum of, you know, the series. So for example, if you put 5 in here, it will give you the sum of the first 5 terms. I mean, we could have found this in many ways. I could have put s equals, for example, 10 and s equals 20, and I could have, you know, used those values to work out what a and d are. But this is the easy way. N equals 1 will give you the first term. N equals 2 will give you the sum of the first 2 terms. So the sum of the first 2 terms is 12. That means the second term must be 7. So you know the first term, you know the common difference, and then you can proceed. So it's not that difficult. It looks like it's a bit of a tough question, but once you just understand that you can generate the sum by just putting different values of n in here, that will make life very easy for you. So that sums up this question number 4. Other questions from this paper will be found in the playlist, which will appear on the top right of the screen at the end of this video. Other questions from the topic of series, you'll find them in this playlist over here from my Cambridge collection. I'll also put my series collection from P2 of Edexcel over here. You can subscribe to my channel by clicking on the link on top. Thank you for watching and see you soon.